Okay, now let's see this question. This question came in GATE 2015 for 2 marks. So let's see this question. They are saying that assume that a merge sort algorithm in worst case takes 30 seconds for an input of size 64. Okay, so if the input size is 64, the merge sort algorithm is taking 30 seconds. Okay, now they are saying which of the following most closely approximates the maximum input size of a problem that can be solved in 6 minutes. So basically they are saying that okay, if our merge sort algorithm implementation for in 30 seconds, if it is able to solve a problem of size 64, then in 6 minutes what is the problem size is going to be? That is their question. Okay, so first of all we have to know in this question is that what is the time complexity of merge sort algorithm. Okay, this one you should know, then only you can solve this question. And we all know that the merge sort algorithm runs in theta and log n time, right? Theta and log n time. Okay, and basically theta and log n time is literally meaning something like c1 into n into log n. Okay, where c1 is some constant. Okay, now let's fill in the values in each of the cases and then we will figure out how to solve this. So we are talking about one equation where c1 into the size is 64 and its log, so 64 log 64, and this takes 30 seconds, right? Okay, this is our first equation. The second equation is c1 into, now we don't know the size, let that size which we have to find, let that size be x. So x is the size which we have to find, so x log x, and that is going to be 6 minutes, and in the above equation 30 is in seconds, so 6 also we will convert it into seconds, which means 6 into 60. So this is equation number 2. Now when we divide equation number 2 by equation 1, then we get something like this. So c1 gets cancelled, so we will get something like this, x log x, right, and divided by 64 into log 64, which is basically 6, okay, is equal to then it will be 6 and into 60 divided by 30, so 6 into 2. Okay, so this is going to be the equation. Now let's solve this equation. So from this we can write x log x is equal to, now I can write basically 12 into 6 into 64. Okay, so 6 into 12 into 6 into 64, this is the equation which we have got. Now in order to solve this equation, like you cannot directly evaluate it. If you have a calculator you can try that, but the easiest way is that the right hand side, if we can somehow put it in a pattern of x log x, then we can simply correlate the value of x and we will get that. Okay, so let's try to fit the pattern of x log x in right hand side also, and we can do that something like this. See this right hand side, 12 into 6 into 64, it can be written something like this. So let's just factorize and take all the factors of 2. So 12 can be written as 3 into 2 square, which is 4. So 4 into 3, 12 can be written. Similarly 6 can be written as 3 into 2, and 64 can be written as 2 raised to the power 6. Okay, now this entire thing can be written as 2, what is the overall exponent of 6? So 6 to 8, 19. So 2 raised to the power 9 is the overall value in terms of exponents of 2. Then the remaining value is basically 3 square, which is 9. So this, and now you are getting the pattern that 2 raised to the power 9 into 9 can be written as log 2 raised to the power 9, isn't it? Okay, so once we do that, we can simply see that okay, now this fits into the pattern of x log x, and therefore x is equal to 2 raised to the power 9. So basically what it is 512 into log of 512, right? So that is what I am saying, that in that sense we can say that this x is basically 512, right? So x is equal to 512 because x log x is equal to 512 log 512, right? X is equal to 512, so our answer is B, 512.